Good morning, children. Hope everyone are fine. Last class we have studied about in the second chapter the first law of motion. Who proposed the three laws of motion? Sir Isaac Newton has proposed. We have studied about the first law. It's also called as law of inertia. From that one, let us see the example is given. A body of the mass m is kept on the horizontal floor and it pushed in a horizontal direction with a force of 10 and continuous so that it moves steadily. So here the question means a block is kept, okay, the mass m is kept, it moves in horizontal direction. The questions are like this. The force 10 first A is they ask us to draw the free body diagram, B is they ask us to find out the frictional force. So we know that, let us see this mass m. Free body diagram means all the force acting. Force applied by us, frictional force opposite to the applied force, downward force is gravitational force, upward force is normal force. Okay, that is the first answer. And so next, so here in her vertical direction the net force will be 0, and now in the horizontal direction to the force here F net is equal to 0. So force applied by us, okay, minus force plus and minus, it is in a frictional, that is equal to 0. So when you transfer this, 2 becomes 0. So the frictional force also will be 10 and okay, this is about the first law. And the second law is, next is second law of motion. It will be telling us about an object when it is not in the direction, means when the net force is not 0, means it moves. When does it won't be 0? When we move an object, what happens? It moves to some distance and it stops. So here it is not having a 0. If net is not 0, it is having something. Means here, when does we say the force is having no 0, net force is not 0, non-zero? When the equilibrium state disturbs. Listen, when you push a ball, what happens? It moves to some distance. So in order to know about objects when they are moving, when the non-zero force, okay, we'll be learning in the second law. So before moving that one, we have to know about the concept of momentum, linear momentum. Okay, linear momentum means linear in a straight path. Momentum means just moving. Let us take some examples. Okay, for example, badminton ball and the cricket ball, which hits you more fast, badminton ball or cricket ball? And next, a small bullet from a gun to the wall. What happens? Even the wall is large, the bullet hits the wall. And next, bicycle and the truck. Which one will be damaging the wall? Truck. So here this momentum, when they are moving, what happens? It depends upon the mass and the speed of an object. Yes or no? So in order to know this momentum property, will be motion of an object, will be learning the momentum. Momentum is denoted with the letter P. This is denoted with the letter P. So the product of mass and velocity is called as a momentum. Okay, the product of mass and velocity is called as momentum. So here Newton told mass in motion. Okay, he based upon the concept mass in motion, he denoted the word as a momentum, that is P is equal to mp. M is mass and B is velocity. So how can we say physical quantity of momentum? Velocity vector, so momentum is also a vector. And what are the units for the momentum? Is kg minus meter per second or Newton minus seconds. Simply we can write Newton per second. This is about momentum. Means in order to learn about second law, we'll be knowing about the momentum, because the object in the second law determines us when the net force is not 0, non-zero, means it will be in the not in the rest position, it moves. So when it is moving, it will be depending upon what mass and the velocity. This depending upon the mass and velocity. So we call the product of this mass and velocity as what? Momentum. So children, okay, you will write out the definition of the momentum. Second law will be learning mass in motion. Newton tells the mass in motion. And same okay, we'll be having here activity 4 and the activity 5 will be telling about the larger the net force, greater the acceleration. Larger the net force, greater the acceleration. Means the force is more, what happens? It moves fastly. Okay, here larger the net force, and larger the mass, smaller the acceleration. Is it or not? It is easy for us to move the bicycle than the car. So here, if the mass is less, we can move. If the mass is more, we cannot move. So based upon this, okay, we'll be denoting a momentum. We'll be denoting a momentum here. Whereas the larger or smaller, some force is applied. Here the second law will be telling about the change in the movement of an object. Change in the movement of an object. So thus F net force, F net is directly proportional in the mass by time, momentum by time. So F net is proportional to delta P by delta T. Now to remove the so in order to take the proportional, we will be using a constant K. F net is equal to K delta P by delta G. So SI unit of the momentum and time is kg meter per second respectively. So now take out the proportional, we will be using a 1. So F net is equal to delta P by delta T. So P is equal to mv. So we will substitute in the this one delta P. So delta P is equal to m delta V. So in the place of delta P, what we have substitute? M delta V. So F net is equal to m delta V by delta T. So we know delta by T by delta T is also called uniform. So delta V by delta E is an A, that is what it is called uniform acceleration. So F net is equal to m J V. So F net is equal to m according to the second law will be denoting about the mass and the acceleration. Means the place of delta V by delta T we will be substituting a. So F net is equal to m A. So here the center of the force is kg meter per second square. This unit was named after the Newton, and 1 Newton is equal to 1 kg meter per second. So you can use this F net is equal to delta P by delta T as universal laws, and F net is applied to some systems at the constant. Okay, this can be solved by using different problems. Okay, F net is equal to MA. Now this is a concept you have learned here, and F net is equal to delta P by delta T. In place of proportional, we will take key in the K, in the place K we will be keeping 1. In the place of delta P, we know that mass is mass into velocity. Substituting that, we are getting F net is equal to m delta V by delta T. Delta V by delta T is here. So write in your notes. Thank you.